continuing in Chapter 3. One of the things we're going to start working with is if we have a function which is a higher degree than a quadratic, so maybe a cubic or a quartic or a quintic or anything higher, we need to be able to find solutions for that. The tools we've so far looked at only work for quadratics. So we need to add some tools into our toolbox to be able to get solutions for these higher degree ones. We're going to add the first one, which does increase how many things we can solve, how many equations. It's not going to give us everything. It's only going to work for certain class of equations, but it does expand the number of equations that we can solve. In order to use that technique, we have to do a lot of division of polynomials. And division of polynomials is not necessarily a fun thing to do. It can be very tedious. Fortunately for what we're doing, the polynomial we will always be dividing by is always going to be a first order. So it's just going to be a binomial with a first order value for x to the first. That's all we're ever going to divide by. Because of that, we can use a very specialized type of division known as synthetic division. How many of you have seen synthetic division previously? Yeah, just the one, okay. I had not. They didn't use this when I was taking algebra either, but it's very useful. It only works when you're dividing that type. And the way it works is you eliminate all the x's. You just take the numbers. So essentially what we're going to do is we're going to take the number that's in the divisor. We're going to take the opposite sign. It's a -1. We're going to put a +1 here. We're going to write the coefficients of the numerator underneath here with their sign. So this is a +5, that's a +1, that's a -3. Just the coefficients. You have to write every one of them. If there's anything missing, you must put a 0 there. Just like you do for any polynomial division, you have to represent a missing thing by a 0. We do that. Then we draw a horizontal line, leaving some space in between. We bring down this first number. Don't do anything at all to it, just bring it down. Write it below the line. Then I'm going to take this number written outside here, and I'm going to multiply it by this number here. So 1 times 5, and I'm going to write 5 up above the line now in the second column. So I'm going to write 5 up there. All I did was 1 times 5, and I write it up there. Make sure you use the sign rules. If you have pluses, use pluses. If you have minuses, use minuses. Normal sign rules for multiplication. So 1 times 5. Now I'm going to take these two numbers, and I'm going to add them together. 5 and 1 make 6. Now I'm going to take this number here times this number here. 1 times 6, and I'm going to write 6 up above the line. Now I'm going to add these two numbers together. -3 and +6 give me a +3. That's synthetic division. What that tells me is that the result of this division is going to be the expression. I'm going to take this number and use it as a coefficient on x, and the exponent on x is going to be 1 less than that one. So this is an x squared, that's going to be an x. This next number is the coefficient on the next lower value of x, next lower exponent. Since that's 1, this would just be the constant term. This last term is the numerator of a fraction. That's your remainder part, and the remainder in a polynomial division is always a fraction. The fraction is made up by taking that number and dividing it by this x minus 1. So to do this division, we have not done any division anywhere. All we've done is multiplications and additions. No divisions, no subtractions, multiply and divide. Multiply and add, multiply and add. Then recognize what this bottom line means. These are coefficients of what's known as the reduced polynomial. And we're going to write those, and whenever you're doing polynomial division, you have to include that fraction. So make sure if you're doing this, just a normal synthetic division problem, that your answer is written including that. So once we get it, we look at what this exponent is. We take this coefficient times x and write x, the exponent just to be 1 less. Then whatever this sign is and this number, and then it's going to be times x to 1 less. So this is 1, that would be 0, or in other words, a constant. On the last column, write a plus and a fraction bar. Put whatever this number is with whatever sign it has in the numerator. Put this divisor in the denominator, and that's your answer. Okay, let's do another one because that's rather a long explanation for what's going on. But there's what we're doing. If you divide a polynomial by this type of form, x minus a number, then you can use synthetic division. And this is an explanation of what I just went through. It's rather long and involved, that's why I showed it first. This is listed in the textbook, and you can also read it here. Since I went through all those words already, rather than read this off to you, you can read, so I'll let you read it yourself later. But you need to make sure you understand the process. So what I want to do is I want to do another example. And I'll actually work through this one manually. If we're going to do this division, we first need to recognize that we can use synthetic division. The way you recognize that is that your denominator is x minus a number, or x plus a number. That's the only thing we're going to use for synthetic division. But fortunately, that's the only thing we need to use for what we're about to do. But you must have your denominator as x plus or minus a number. Nothing else works. Can't be x squared. It's got to be x. In order to do this synthetic division, we're going to look at this number in the denominator. Take the number with the opposite sign. That's a minus 3. What I'm going to do is I'm going to write a plus 3 out here. Then I'm going to put my division symbol. And I think some books use a little different symbol. I'm going to use this. And underneath here, I'm going to write these coefficients with their signs. So it's going to be a plus 4. It's going to be a minus 15. It's going to be a plus 11. And it's going to be a minus 10. And I'm leaving spaces between here because those are different columns. That's not adding and subtracting. Those are completely different columns. What I have to ensure I do here is that every power of x has a column. I need a column for the x cubed, I need one for x squared, I need one for x to the first, I need one for the constants. Every column needs to have a location. If it's missing in the numerator, you put a 0 in here. But you must have it. Now, I've written my numbers. Notice no x's anywhere. Leave a gap and draw a line. Take the first number underneath the divide symbol and bring it down below the line. Don't change it. just bring it down. Take this number outside here. It could be positive, it could be negative. Multiply it times that. This is plus 3 times plus 4. Write that number up above the line in the next column. Not in the same column, in the next column. So 3 times 4 gives me 12. Now add that column. And you get a minus 3. Take this number, multiply it times that number, write it up here. 3 times minus 3 is minus 9. Add that column. Take 3 times 2, write it up here. Add that column. I don't have any more columns, so I'm finished with this part of it. This is not the answer, obviously, because the answer to a polynomial division is a polynomial and a fraction. So I have to take these numbers and from that construct my answer. So what I'm going to do is I'm going to take this first number and I'm going to multiply it times x, and the exponent I'm going to put on x is 1 less than this other. So this is 3. I'm going to put 2 over here. That's the exponent I'm going to use. 1 less than that one. Then I just walk down the exponents. So I'm going to get minus 3 and x to the first power, because the next one after 2 is 1. Then I'm going to put plus 2. This is a plus sign here. I mean, it's a positive 2, so it's a plus 2. And I've run out of x's, so that's my constant term. I have one number left. I'm going to put a plus and a fraction bar. And in the numerator, I'm going to put that number, minus 4. And in the denominator, I'm going to put this denominator. And that is the quotient from that division. We didn't do one single division. We did multiply and add. So it's an extremely simple, extremely compact method for doing division. Must have that form for your denominator. But then it's quite simple. And the reason I'm showing this, we're going to be doing a lot of these divisions in this next thing we're going to do. And so you're going to have to do, you can use the standard way of doing division, but it's much more laborious. This is much easier. You can actually use this anytime you're dividing polynomials of this type. So any other problems where you encounter this, I suggest you use this because it's so easy. I certainly am happy I learned about it finally, because I always did it the long way. Okay, so that's the technique. The long way would be to do this. 4x cubed, and then you x into that is 4x squared, multiply, that long way. You don't want to do that. So that's what we wound up with this division. And that's all it takes. This division takes 1, 2, 3, 4 lines to do. So very simple, but very useful tool. Yes. This always is the denominator of your fraction. Always. Whatever this denominator is, that's what that denominator is. And everything should have a fraction. Now, if this number turns out to be a 0, you'd have 0 over that. which is just 0. So you don't have to write that one, that's 0. But yes, this is always this. The rest of this should be a polynomial. You should not have any fractions in here. It'll be polynomials. Remember, this exponent is 1 less than this one up here. Exactly 1 less. Remember to have every power represented. Okay. So here's another one. If we want to do this, you can divide this however you want. But let's do it by synthetic division. So how do we set it up? If we're going to do this by synthetic division, how do we set the problem up? That's a +2, so I'm going to write a -2 outside. I mean, remember, the opposite sign outside. And what am I going to write underneath? Don't forget that that is a 1. You have to put a 1 there. So don't leave it off. Then what? Just write them down. Oh, come on, Lord. Then what? Draw a line so that I have something to write above and below. And then one down all the way to the bottom. That times this, and where do I write it? Under the 7 up here. Then do what? Well, what word do you want to use? You combine those two numbers using the sign rules. Is that subtraction or is it adding a negative? The technique says add those two numbers. One of them's positive, one of them's negative. That's what the technique says, is to add. But whatever you call it, it's combining these two numbers using the sign rules. Then repeat. Notice this time, our last number is a 0. That means there's no remainder. This will divide into that an even number of times, or in other words, no fraction. So when I write my answer for this, what is my answer going to be? And I could put, but there's no reason to put that because it's 0, so just leave it off. That's only when that number's 0. Now what we're about to do, we want that situation to be true where that number is 0. That's what we're going to be looking for. And we'll actually be using this as a test to see when that's true. So you actually carry out the division, and if you get 0, that's a success. If you don't get 0, then you need to try something else. That's the technique. Not difficult. Very can't think of the word I want. Very useful, very beneficial. All right, let me give you one. So how do we set it up? Really ought to be a name for that, but I've never seen one as far as I know. What goes under there? 1 and -1, right? With a bunch of zeros. That's 5. I need a 0 for 4. I need a 0 for 3. I need a 0 for 2. I need a 0 for x to the first. Then I can write my constant. If you don't put those zeros in, you're going to get the wrong answer. This is the x to the fifth term. This is the x to the fourth column. This is the x cubed column. This is the x squared column. That's the x column, and that's the constant column. You need every one of those columns. When you're missing that power, you must put a 0 in that column. Otherwise, your answer is wrong. And I don't know what C for constant, yeah. And notice what I did is I put a plus a fraction. If you always put a plus there, you don't have to be concerned about how to put the signs in. You just bring this number and put it in the numerator. It's a -2, I'll put a -2 in the numerator. That way you don't have to be concerned with signs. Always add your fraction, always include this sign in the numerator. That's a perfectly valid way to write that fraction. So. Remember, don't leave any columns out. You must have those columns in there. Notice what happened. I only had the fifth power and the constant here, but in the quotient I had everything else. And if you don't put those in, you won't get those terms. Okay, the way we're going to use this synthetic division. If we take a polynomial and divide it by a binomial of the form x minus k, what we get is the same thing we would get if we plugged k into the function. So we got f of x. If we divide it by x minus k, that's exactly the same answer we would get if we took f of k. So that previous function that we looked at, there's the function, f of x. If we plug the number 3 in, if you look back at the problem we did, that was the previous problem here. K, x minus k, so k is 3 in this case, right? So our value k is 3. We're looking at this function, this division. And, okay, what we got for an answer is 4x squared minus 3x plus 2 in the fraction. If we plug 3 in, we get that, which is -4. -4 is that remainder part. That's the remainder we got when we did the synthetic division for that problem. That was the numerator of the fraction. So if you plug the k value in to the function, you get the remainder value. Because it's x minus k. And we had 3 outside. The The way we incorporate this concept in is that if we evaluate f at some number and we get a zero remainder, that's called a zero of that function. So anytime you plug a number into a function and do the calculations and you wind up with zero for an answer, whatever number you plugged in is a zero of that function because it gives you zero for an answer. That means the remainder is zero. Or in other words, that x minus k divided evenly into that polynomial. The reason zeros are important is that those zeros are x-intercepts on the graph. X-intercepts are real valued solutions to the equation. So zeros and solutions are the same thing. So if we find zeros, we find solutions. And we're looking for solutions. And if solutions and zeros are the same thing, if we have a way to find zeros, then we have a way to find solutions. And so here's a way that if we can figure out a way to pick numbers such that we get zeros, then those numbers are solutions. And we show that. So let's assume we have some way to pick numbers. How can we be sure that it's a solution? Well, we're going to take the number and we can either do the synthetic division with that number or we can plug it into the function like we just looked at. Either one will tell us what the remainder is. We want to look for a remainder of zero because that's what the definition of a zero is. It's a remainder of zero. So if we can find a number which has a remainder of zero, then we have a zero. You can find it either by using synthetic division to test, or you can just substitute the number into the function and calculate the function. For instance, is -3 a zero of that function? We can do the synthetic division. Because we're saying k is -3, this is what we do. I'll wait for later before I do that. So we're going to test -3. So we put -3 out here. We put the coefficients under here. We do the synthetic division. And our last number here turns out to be a zero. Therefore, -3 is a zero of this function. That's one way to test it. The other way to test it is to take -3 and substitute it in for x. And so that's what I'm looking at here. We could put -3 in there. And you go through the calculation and you get 0 for an answer. Therefore, the remainder is 0. Okay, -3 is a 0 of that function. Now, the comment I made at the bottom of this page over here is a useful piece of information. This synthetic division here we're doing here, we're looking at it using real numbers, but you can do it with imaginary numbers too, complex numbers. Now you want to start with real numbers here. You don't want to, well, I shouldn't say that. The way we're going to be using it, we always want to have real numbers there. But you can do synthetic division on complex numbers. So, two different ways that if we have a number, we can see if it's a 0. That doesn't tell us what numbers to use. It just says that if we select a number, we can check whether it is. And it either is or it isn't. You can't make it become one. All you can do is test a different number. Well, that maybe it doesn't sound very helpful because there are an infinite number of numbers, right? So how do we know which numbers to test? we're going to look at next is how you pick numbers like that. But let's look at this again, the test. How do you determine if k equals -5 is a zero then? Which technique do you want to use? And you choose which one you want. There are advantages and disadvantages to both. So pick a way, and is -5 a zero of this? I normally choose this way. I think it's a little less work than the synthetic division, but this has the disadvantages also. We'll get to those in a minute. I plugged the number in. In place of X, I put the number. And then just did the arithmetic. On the slide, I did the synthetic division. For this one, it actually turns out probably a little less work on the synthetic division. But if you have a long polynomial, this probably is not the case. So -5 is a zero. Because that -5 is what I'm testing. So I put -5 out here. You change the number when you're starting from this, one of those two. We're not starting from that. We're starting from here, or being combined with the X. This doesn't have an X anywhere in this. So it just says the number. What we're talking about is just this piece of this. All we're doing is we're looking at this part. So that's why we don't change it. Okay, y'all do this one. Is that a zero? And if you attempted the one way on the previous one, do the other way on this one. Just try both ways. Not zero, so it's not a zero.